Hello and welcome to Trigonometry. My name is Donna Langley and I am the instructor for this course. Before we get started, let me just say that I have posted a Start Here module on Blackboard. Please log into Blackboard and work through the Start Here module. In the Start Here module, you will find many important things, such as the required textbook for this course, the syllabus, which includes how I do grading for this course, as well as the MyOpenMath course ID and enrollment key, course calendar, course policies, university policies, as well as standards for communication. My email is posted in multiple places, including on this slide. You also need to check your email regularly. The time commitment for this course is about 8 to 12 hours per week. Please choose times of day and times of the week where your brain is most focused, where you are most able to think critically and deeply. We are working on a journey to comprehensive mastery. UAA's guidelines for grades says that in order to earn an A in the course, you must demonstrate comprehensive mastery. To get there, there are multiple paths to learning, and these include posted lectures, textbook reading, MyOpenMath videos, and optionally other resources from the internet such as Khan Academy. I will be posting these lectures twice a week. Your textbook, of course, is available for you all the time, and I would encourage you to start reading your textbook. You do not need to read every word, but focus on the vocabulary that is presented, skim through the examples, make sure you note how the examples are worked out and what sort of work is demonstrated, and just become overall accustomed to the layout of the textbook. On MyOpenMath, under many of the questions, you will see that there is a help video posted. And if you watch the help video, you'll be able to see a more detailed explanation as to how to do a particular type of problem. These help videos are posted by various different teachers, different instructors. So try out some help videos and see how they work for you. Another option is Khan Academy. Khan Academy is a great place to go if you are struggling with a particular concept and you want to watch some videos and do some practice exercises to master a particular concept. If you're having some difficulty, you will find the Meet Help section in the Start Here module. There are 3 that I want to highlight briefly. The Virtual Math Lounge. This is a math homework lounge that I'm creating on Zoom. The hours are limited right now because this is still experimental, but I hope that you will make use of this math homework lounge. Show up to work on math with other students. There is more than one section of this trigonometry course, and so I have invited both sections to the same math homework lounge to increase the probability of you running into each other. You all have the same homework assignments. Matsu College tutoring is also available, and it is free. That is, it's already included in the cost of tuition and fees. Another option is tutor.com, which usually costs money, but if you go through SLED, and the link again to both the Matsu College tutoring and the live homework help is where the help button is on the Start Here module. But SLED will give you free live homework help through tutor.com, and you do not have to pay for it. If you want help from the instructor, there are 2 different types of help, office hours and the homework lounge. Office hours are if you fall behind or if you're concerned about low performance in the course and you want to meet privately with me in order to create a plan to get you back on track. Whereas the homework lounge would be a great place to meet if you need help with a particular concept or a particular homework, and we would meet with other students and we could all discuss it together. I will be showing up to the homework lounge, sometimes announced, sometimes unannounced. Speaking of homework, if you want to find it, go to Blackboard. You will see underneath the Math Homework Lounge, Unit 1 Introductory Topics. That's our first unit, and other units will show up throughout the semester. Click on the unit, and you will find the homework. To every homework, there are 2 parts. There is the MyOpenMath part of the homework and the textbook part of the homework. Both parts are required for full credit. Quizzes and tests are found only on MyOpenMath, so you will not find them on Blackboard. Log into MyOpenMath and find all your quizzes and tests as they become available. Okay, so now we are heading into Chapter 1, and I'm going to go through some of the concepts that are most important for you to get your homework done and for you to understand for quizzes and tests. Hi, here I am. I'm actually on campus at Matsu College because I need a whiteboard. I have the laptop propped up on a trash can right now. So hopefully this angle will work well and we can work through the material effectively. The first concept I want to talk about is complementary and supplementary angles. Complementary angles are when two angles add up to 90 degrees. So for instance, 42 degrees plus 48 degrees is equal to 90 degrees. That would be complementary angles. Supplementary angles are when two angles add up to 180 degrees. So this time, 42 degrees plus 138 degrees is equal to 180 degrees. Next, consider problem number 30 from page 8. There are two supplementary angles. The measures of these angles are 6x minus 4 and 8x minus 12. We are to find these two angles. So, because they are supplementary, they must add up to 180 degrees. And then it's simple algebra from here. X is equal to 14. So that means that the original angles, 6 times 14 is 84. 84 minus 4 is 80 degrees. And the other one better be 100, right? So 14 times 8 is 112. 112 minus 12 is 100. So by finding both of them, then when we add the two together, they add up to 180 degrees, so then we know that we are correct. When it comes to angles, there are two different ways to write them. One is in decimal form, and one is in DMS form. DMS form is degrees, minutes, seconds. And just as in the case of hours, there are 60 seconds in 1 minute and 60 minutes in 1 hour. So 60 seconds in 1 minute, 60 minutes in 1 degree. Suppose you had 5 degrees, 3 minutes, and 42 seconds. Okay, so here's the notation. The degree symbol you should already be familiar with. But when you have 1 notch, that would be minutes, and 2 notches is seconds. We want to convert degree, minute, second form, DMS form, to decimal form. Remember that there are 60 minutes in a degree. So that means that this 3 minutes is 3/60ths of a degree. So we have 5 degrees plus 3/60ths of a degree. If there are 60 seconds in a minute and 60 minutes in a degree, 60 times 60 is 3,600. That means there are 3,600 seconds in a degree, just as there are 3,600 seconds in an hour. So now 42 divided by 3,600 will give me the amount of seconds in decimal form. So now all I have to do is type all this into the calculator. By the way, if you need a graphing calculator, I checked mine out from the Matsu library. So go and check one out. You can get it for the entire semester. Hopefully, this one has batteries. I haven't checked it. Yay, it does. Okay, so 5 plus 3 over 60 plus 42 over 3600 gives me a total of 5.0617 degrees. I did round. I rounded right here at this point. So that would be through 4 decimal places. When it comes to rounding, just follow the directions in the book or on MyOpenMath. So that is how you convert DMS form down to decimal form. What if you start with decimal form and you need to convert it to DMS form? How do you do that? So let me just make up something. 42.9218 degrees. Okay, so you do this one on the calculator. We know that we have 42 degrees. The next question is, how many minutes do we have? So you take 0.9218 and multiply it by 60 on the calculator. So this is roughly 92% of 60 is 55.308. So I have 42 degrees and 55.308 minutes. Now I need to take this fraction of a minute and convert it to seconds. 42 degrees, 55 minutes, and how many seconds? Take again the decimal and multiply it by 60. So previously we took 0.9218 and multiplied it by 60. Now we take 0.308 and multiply it by 60. And that is 18.48 seconds. Usually a problem will tell you to round to the nearest second. So in this case, the final answer is 42 degrees, 55 minutes, and 18 seconds. Here we are on myopenmath.com, homework number 1. Let's look at question number 6. I'm adding together 4 degrees, 11 minutes, 28 seconds, and 1 degree, 9 minutes, and 12 seconds. So 4 plus 1 is 5. So I have 5 degrees. Then 11 plus 9 is 20. So then I have 20 minutes. And 28 plus 12 is 40. So I have 40 seconds. Okay, so here I'm going to have a new version of question 6. So question 6 is not showing up. What's wrong? Okay, hold on. Here we go. Here is a new question 6. The reason I wanted to look at this one is because we have some extra difficulty here when we're adding 42 minutes and 26 minutes. So let's start with 191 plus 47 is going to give us 238 degrees. Next, 42 and 26 is 68 minutes. And 8 minutes and 2 minutes is, these are seconds. Let me say that again. 8 seconds and 2 seconds are 10 seconds. So what do we do when we have 68 minutes? 68 minutes is the same thing as 60 minutes plus 8 minutes. That means I need to take the 60 minutes and turn it into an extra degree. So I end up with 239 degrees 8 minutes and 10 seconds. Question 7 is harder because you have to do subtraction, and subtraction requires you to carry. There is a problem like this in your textbook, so I'm going to actually have you look at your textbook for this one. For help with number 7, see number 49 on page 8 of your textbook. One thing I want you to learn is that when a textbook number is highlighted in green, that means the solution is in the back of the textbook. So I want you to read through the solution to number 49, and based off that solution to number 49, apply that same procedure to question number 7. Next, quickly, I want to work through 2 word problems from section 1.1. One is 124. This is on page 9. It says, a windmill makes 90 revolutions per minute. How many revolutions does it make per second? So this is a unit conversion from minutes to seconds. What we want to do is multiply by a unit converter. Minutes turn into seconds. How? If you have 60 seconds, then you have 1 minute. Notice that I have the minutes in the numerator. I know to do that because the minutes in this denominator need to go away. So we can cancel out the minutes in the denominator with the minutes in this numerator, and that leaves us with 90 revolutions over 60 seconds. over 60. When you are giving a unit rate, you always have a 1 in the denominator. So 90 over 60 is the same thing as 1.5. So therefore the answer is 1.5 revolutions per second. Next, I want to look at number 126. And this one says, an airplane propeller rotates 1,000 times per minute. 1,000 times is the same thing as 1,000 revolutions. So rotates 1,000 times means 1,000 revolutions. Find the number of degrees that a point on the edge of the propeller will rotate in 2 seconds. How many degrees are in 1 revolution? We need to convert revolutions to degrees. There are 360 degrees in 1 revolution. I put revolution in the denominator because the revolution up here in the numerator needs to cancel with this revolution. Revolution in the numerator cancels with revolution in the denominator. Now my units are degrees per minute. I don't want degrees per minute, I want degrees per second. So I multiply now by another unit conversion, minutes to seconds. There are 60 seconds in 1 minute. Now the minutes cancel. One is in the numerator, 1 is in the denominator. So what this leaves me with is 1,000 times 360 degrees over 60 seconds. And I would just go ahead right here. 360 divided by 60 is of course 6. Then 6 times 1,000 is 6,000. So this is 6,000 degrees per second. So how many degrees in 2 seconds? 12,000 degrees. So that would be 12,000 degrees per 2 seconds, which is what the question was asking. Another concept in this course that is really important is coterminal angles. We will be interacting a lot with angles that are on an XY plane where the vertex of the angle is at the origin. The vertex is at the origin, and one of the rays is on the positive x-axis. This is the initial side. Initial side. The other ray is called the terminal side. So this angle is in standard position. Standard position has the vertex at the origin and the initial side on the positive x-axis. Here is your angle. So suppose this is 110 degrees. Notice that degrees are counterclockwise. So starting here at the positive x-axis and moving counterclockwise, we work through 110 degrees. Now, if we go in the opposite direction, then we have negative degrees. Going clockwise, negative degrees. So starting here and working back this way, of course these two must add up to 360 degrees because this is a full circle. So going back this way, we have negative 250 degrees. Counterclockwise is positive, clockwise is negative. And when we start at the initial side and end at the same terminal side, these are coterminal angles. Coterminal angles have the same initial side and the same terminal side. However, they might work through the angle in a positive direction, in a negative direction, or might go around multiple times. Okay, so another example would be if I start at this initial side. Let me erase this one so it doesn't get too cluttered. So let's say I start again at the same initial side, but this time I go around, basically around 1.5 times roughly. So I go around a full circle, 360 degrees, plus an additional 110 degrees. So 360 degrees plus 110 degrees is going to be 470 degrees. So these are coterminal angles. What if the problem asks you to find an angle that's coterminal with a given angle? So, for example, let's say you are given 912 degrees. 912 degrees is not between 0 and 360. And in this course, we regularly need to work with an angle between 0 and 360 degrees. So we can convert 912 degrees to something in between 0 and 360 by finding something coterminal. You notice in the previous diagram, I added 360 degrees onto 110 degrees to find a coterminal angle. Similarly, you can add any multiple of 360 or subtract any multiple of 360 to get to a coterminal angle. So if I subtract 360 degrees from this number, I end up with 552, right? 8, 9, 12, yes, 552 degrees. 552 degrees is coterminal with 912 degrees. These are coterminal angles. However, 552 degrees is not between 0 and 360. So we subtract 360 again. (192 degrees). degrees. Okay, 192 degrees is coterminal with 552 degrees, which is coterminal with 912 degrees. 192 degrees is between 0 and 360 degrees, so this would be the angle that we would want to work with. So if the directions say find an angle coterminal with the given angle between 0 and 360, then you want to add multiples of 360 or subtract multiples of 360 till you bring your number between 0 and 360 degrees. We just covered section 1.1. Section 1.2 is a review from high school geometry. So I'm going to put the ball in your court here, which actually it is anyway. I need you to be the master of your own learning. Choose modes of learning that are most effective for you. If you get a lot out of textbook reading, then read more from the textbook. If you get a lot out of watching videos, then watch more videos. Do whatever you need to do to master the content. 1.2, you can read the textbook, you can watch the videos from My Open Math, or you can go to Khan Academy and find the topics covered here in the geometry section. Since this is a review of high school geometry, I'm going to leave this to you and move on now to 1.3. Section 1.3 starts with a review of the Pythagorean theorem and the distance formula. You see here on My Open Math, we have a Pythagorean theorem problem with an accompanied video and the distance formula with a worked example. Now, when it comes to a distance problem, you can either choose to use the distance formula or you can use Pythagorean theorem. Let me show you how to find the distance between 2 points using the Pythagorean theorem. The first thing you would do is you would want to set up a little xy plane and plot the points. 2, -1, and -3, -2. Next, you want to draw a straight line between these 2 points. That line segment right there represents the distance between these 2 points. Next, what you want to do, and let me use a different color next, is look at the vertical distance between the 2 points. This vertical distance is 1. Next, let's look at the horizontal distance between the 2 points. The horizontal distance goes all the way from -3 to +2, and that would be a distance of 5. Now this is a right triangle because I looked at the vertical distance and the horizontal distance, so this is on a grid. Now I can use the Pythagorean theorem, so this will be my C, and I have 1 squared plus 5 squared is equal to C squared. So that gives me that C is equal to the square root of 26. You can get the exact same results using the distance formula as well. It's a personal preference. So when you work through questions 19 and 20, you can refer to page 22 in your textbook. That's where you're going to find the Pythagorean theorem and the distance formula. Okay, so next we want to look at the definitions of the trigonometric functions, and they are found on page 23 of your textbook. So if you have a point on the terminal side of a standard position angle, so let's say this is my standard position angle. The initial side is on the positive x-axis. The vertex is at the origin. And let's say this point right here is 1, 5. Okay, so the radius of the circle that is formed is going to be the distance from the point to the origin. And in the same way as the previous problem, I used 1 and 5 so that you can remember that the hypotenuse was the square root of 26. And it's found the same way. The radius is equal to the square root of 1 squared plus 5 squared. So the radius of this circle then is the square root of 26. Now each of the trig functions is defined for you as a combination of x, y, and r. So you will see that the sign is going to be y over r, and we have a Greek letter here, theta. So the Greek alphabet is introduced in this book in 1.1. By the time I studied Greek in graduate school, I actually knew most of the Greek alphabet from studying math. And so if we go through all of these on page 3, you can see the Greek letters in lowercase and uppercase, and as well as how to pronounce them. So this is the Greek letter theta. And this theta is going to represent the angle that goes from the standard position, angle that starts at the initial side and goes to the terminal side, and it goes through 1, 5. So the sine of theta is defined as y over r. Therefore, the sine of theta in this problem is going to be 5 divided by the square root of 26. 5 over root 26 has an irrational denominator, so we need to rationalize this denominator. Multiply by root 26 over root 26, and then we see that our final answer for the sine of theta will be 5 root 26 over 26. In the same way, we can find cosine of theta, tangent of theta, as well as the reciprocal functions, cotangent, secant, and cosecant. These are all defined for you in a green box on page 23. So now, when we move over to My Open Math, we see this problem right here. Given the point 4, 3 is on the terminal side of an angle theta, find the exact value of the following. Now what's really nice about this is 4 and 3 are sides that are part of a Pythagorean triple. So this would be a 3, 4, 5 triangle, meaning that the radius of this circle would be 5. Remember, the radius formula is found in that green box on page 23. So since sine of theta is defined by y over r, that means that my sine of theta, in this case the y value is 3, would be 3 over 5. Let's take another one. Let's look at secant of theta. How is the secant of theta defined? In the green box on page 23, the secant of theta is defined as r over x. So this would be 5 over 4. So that's how you figure out the answers to all of these. Of course, you could always go back to SOHCAHTOA. If you're a big fan of SOHCAHTOA, you could figure that all out quickly that way. But you are allowed to use your book and notes on quizzes. So since these formulas on page 23 are really fast, I would encourage you to use them for your homework, your quiz, and your test. So next I want to take a look at page 28, number 30. Here we have sketch an angle theta in standard position such that theta has the least positive measure and the given point is on the terminal side of theta. So that means I start with the xy axis, and I have my initial side always on the positive x-axis. And let's find the point negative 2 root 3, 2. Negative 2 root 3, 2. We'll go back this way and then up a little. So let's say that this is the point negative 2 root 3, 2. So the other ray, the terminal side of the angle, must go through that point. And we want a positive angle that is the least positive angle, which means that theta is simply this angle right here. Now we need to find the value of the 6 trig functions. We have x, we have y, we just need r. Remember the formula for r. R is equal to the square root of x squared plus y squared. So, if x is negative 2 root 3, what is negative 2 root 3 squared? 12. What is 2 squared? 4. So, the r value is actually a very nice number. The square root of 16 is 4. So now we'll go through the 6 trig functions. Make a little room here. Sine of theta, cosine of theta, tangent of theta. Sine is y over r. Cosine is x over r. Tangent is y over x. Y is 2. R is 4. X is negative 2 root 3. R is 4. Y is 2. X is negative 2 root 3. And now I simplify each of these. 1/2 negative root 3 over 2. And this one, negative 1 over root 3, must be rationalized. So this becomes negative root 3 over 3. Okay, so those right there are sine, cosine, and tangent, and we also need the other 6, which are the reciprocal functions of sine, cosine, and tangent: cosecant, secant, and cotangent. And those would also follow a similar pattern. I'll just do them down here now. Cosecant of theta is r over y. Secant of theta is r over x. Rationalize that. And then also we have the cotangent of theta, which is x over y. And there you have all 6 of the trig functions for a point on the terminal side of an angle. Okay, so quadrantal angles are a special kind of angle. A quadrantal angle is an angle that lines up with one of the axes. So if the terminal side is the same as the initial side, then that would be a 0-degree angle. If the initial side is on the positive x-axis and the terminal side is the positive y-axis, then that would be a 90-degree angle. If the terminal side is over here, that would be a 180-degree angle. And if the terminal side is down here, that is a 270-degree angle. And these are quadrantal angles because they end up on one of the axes, not in a particular quadrant. Just to remind you of the quadrants, we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4, written using Roman numerals. Starting here in quadrant 1, we work counterclockwise. They are always written using Roman numerals. So the quadrantal angles are special because when we are looking at your values for, let's look at a point right here. This one right here. Let's say this point right here is 1, 0, and this point right here is 0, comma 1. This one over here would be negative 1, 0, and this one right here would be 0, negative 1. Okay, so those 4 points right there all have an x value and a y value. What is the r value for each of these? The r value for each of these is also 1. You can compute it using the formula for r, or you can just think about the logic of this. The radius from here to here is 1. So I have drawn all of these points on a circle with a radius of 1, which incidentally is called the unit circle, which is very important for this course. The unit circle is a circle with a radius of 1. So now when you need to find sine, cosine, tangent, all of those, you can use x, y, and 1 is your r value. So if you need to find the exact value of some angles, for instance, let's say you need to find the cosine of 0 degrees. Recall that cosine is x over r. So 1 over 1 is 1. The cosine of 0 degrees is 1. Let's say you need to find the cosecant of 0 degrees. Cosecant is r over y. R is 1, y is 0. This is undefined. So some of the values for quadrantal angles are defined, and some of them are not defined. But in all cases, you will either get 0, because you have a 0 in the numerator, 1, because both the numerator and the denominator are 1, or undefined, because you have a 0 in the denominator. So this brings us to number 90 on page 28. We have an expression, and we need to simplify this. And the work that you show is substituting the values of each of the trig functions and then simplifying the expression. So here we have 5 times sine of 90 squared. So that means we're going to find the value of sine 90 and then square the result. 2 times cosine squared 270. So we find the value of cosine 270 and then square the result, minus the tangent of 360. So the sine of 90 degrees is going to be, remember that's y over r. The y value at 90 degrees is 1. The r value is 1. So the sine of 90 degrees is 1. The cosine of 270 degrees, that would be x over r. At 270 degrees, cosine is 0 and r is 1, so we have 0. And then the tangent at 360 degrees, 360 degrees is coterminal with 0 degrees. So this is the same as the tangent of 0 degrees. And at 0 degrees, you have a y value of 0 and an x value of 1. So this is also 0. So that means that this entire expression simplifies to 5 times 1 squared, or 5. And that's how you do a problem like that. Okay, so let's now look at number 23 on my open math. We are to compute the exact value at 900 degrees. So what is 900 degrees coterminal with? If you take 900 degrees and you subtract 2 multiples of 360, 2 multiples of 360 is 720. You are left with 180 degrees. Okay, so each of these is actually going to be the same thing as sine of 180 degrees, cosine of 180 degrees, and tangent of 180 degrees. So we can find the sine of 180 degrees y over r. The sine value at 180 degrees is 0, and the r value is 1. If you're having a hard time figuring out how I'm figuring out what the y value is or the x value, the picture for this is on page 25. So you can go to page 25. At the very bottom there is figure number 30, and figure number 30 will show you the values of x, y, and r. And if you look at it very closely, it should make some intuitive sense, so that you don't have to blindly memorize it, but that you should just have an understanding of, oh, of course that would be 1 because I'm moving to the right. Of course that's -1 because I'm moving to the left. Of course that's 0 because I am not moving up or down. So pay attention to those numbers on an intuitive level. So that's how you do a problem like that. So now let's look at number 24. So for number 24, it says to enter 1, 2, 3, or 4 using Roman numerals. This goes back to which quadrant are we in. So let's review the quadrants again. Here's quadrant 1. In quadrant 1, if you move to the right, that means that your x values are positive, and that means your y values are positive because you move up. Okay? Now, if you go to quadrant 2, you're moving to the left. That means your x values are negative, and that means your y values are still positive, though, because you are moving up. When you get to quadrant number 3, now both the x and the y values are negative. So x is negative down here, y is negative down here. And in quadrant 4, you have positive x values again, but your y values remain negative. What does this have to do with sine and cosine? Sine and cosine will mimic the x and the y. So wherever you see sine, you're going to think, sine is going to be the same thing as y. So wherever sine is negative, that would be the same thing as where y is negative. Because remember, sine is defined as y over r, and r is always positive. So the sign of sine is determined by the numerator. And whenever you see cosine, think x. Okay? So here, we're looking for where sine is negative, or where y is negative. So that leaves us with quadrants 3 and 4. And then cosine is also negative, which means that x is also negative. So that narrows it down to quadrant 3. Here, sine is positive, so the y value is positive. So that means quadrants 1 or 2. Cosine is negative, so x is negative. So that would be quadrant 2. That's supposed to be a 2. Let's make it look like that. There we go. That's 2. Here, sine is positive and cosine is positive. Where do you both have x and y positive? Quadrant 1. And then sine is negative, but cosine is positive. That's where y is negative and x is positive. So that would be quadrant 4. Okay, so now when we get to number 25, this is a bit more difficult of a problem. So I'm going to switch over to the whiteboard to do this problem. Okay, so we're going to look at my open math problem number 25. This is the example that showed up for my version of the homework. You will have different numbers in your version of the homework. The cosine of theta was given to me as 1/4. Theta is in quadrant 4. Okay, so let me start by just drawing a picture. Quadrant 4 is right here. Okay, so let's think about this. If I have an angle in standard position with the terminal side in quadrant 4, that means that the cosine value is positive and the sine value is negative. Now let's draw a right triangle. Let's say that this is the point here, and we'll just draw straight up to the x-axis. Whenever you draw right triangles for this setup, always draw the line perpendicular to the x-axis. Okay, so remember that cosine's ratio is x over r. So in this case, since cosine is 1/4, we're going to let x equal 1 and r equal 4. So that means that the side of the triangle right here where x is would have to be 1, and the side of the triangle with the hypotenuse would be the radius, so that would be 4. So the y value would be the missing side. Let's call this b. And if we use the Pythagorean theorem, then we have 1 squared plus b squared is equal to 4 squared, so that b squared is equal to 15, and b is equal to the square root of 15. Now b may be equal to the square root of 15, but that cannot be the value for y, because this is in the negative direction. So the value for y is going to have to be the negative version of b. So y is equal to negative square root of 15. Okay, and now to get the sine value, we do y over r, so that would be negative root 15 over 4. So if that was a confusing explanation, you may also try watching the video from My Open Math, and hopefully between the two explanations, it will click for you. There's also examples in the book that you can look at. So that problem that I did, number 25, everything that I used to do that problem was learned by 1.3. However, you won't find a problem like that in 1.3. I just used all the tools from 1.1 to 1.3 to get number 25 done. But let's look at 1.4. 1.4 is the last part of chapter 1. In 1.4, we are looking at reciprocal identities first of all. Reciprocal identities tell us that sine and cosecant are reciprocals, cosine and secant are reciprocals, and tangent and cotangent are reciprocals. And you can see that on page 30. Okay, and you can use the reciprocal identities like this. For example, I just made this example up. Let cosecant of theta equal 5/2. Find the sine of theta. Well, since cosecant and sine are reciprocals, all I have to do is find the reciprocal of 5/2. And the reciprocal of 5/2 is 2/5. Done. Reciprocal identities are very easy to work with. The only difficulty you might have is when you flip over the number, you may end up with an irrational number in your denominator, in which case you would need to rationalize the denominator. So in 1.4, we are introduced to very important identities. I already said that the reciprocal identities are found on page 30. There are also the quotient identities. The quotient identities tell us that tangent is equal to sine over cosine, and that cotangent then is equal to cosine over sine. Here, I'll put an example of each one here. So for reciprocal, we learned that sine and cosecant are reciprocals. So you could either write this as cosecant is equal to 1 over sine, or sine is equal to 1 over cosecant. Notice that when you write sine, cosine, tangent, you always write the trig functions with an angle attached to them. You don't ever just write sine, cosine, or tangent. We say sine, cosine, and tangent, but you always write the sine function with an angle. It could be an angle like 35 degrees, or it could be a variable representing an angle. In this case, the variable is theta. Okay, and then the other really important identities are the Pythagorean identities. The Pythagorean identities are also found on page 35. And the most important of the Pythagorean identities is that sine squared plus cosine squared is equal to 1. There are 3 Pythagorean identities, and they are all equally important. However, if you just memorize this one, you can derive the other ones very easily. Of course, in this class, since it's online and I let you use your notes in your textbook, you don't have to memorize the identities. Like if you were taking an in-person class with me, I would make you memorize a lot of the identities. The good thing is, if you memorize them, you can use them a lot faster than having to look them up again and again and again. If you want to memorize these, if you want to look at the other 2, you can derive them. So what I mean is that if you take this original identity, sine squared theta plus cosine squared theta is equal to 1, and you go through and you divide each term by sine squared of theta, which you can do because it's an equation, what is the resulting equation? 1 plus cotangent squared is equal to cosecant squared. So that is another one of the identities. Let's say we did this exact same process again. Sine squared plus cosine squared is equal to 1, except this time, let's divide every single term by cosine squared. So if you divide every single term by cosine squared, you end up with tangent squared plus 1 is equal to secant squared. So these are the 3 identities. And they are very important. Now, we will be using these identities throughout the whole course. I'm going to show you an example of how you can use one of them right now. Let's compare question number 25 and question number 26 on my open math. Question number 25 and question number 26 basically tell you to do the same thing, except that in question number 25, you don't have to find all 5 of the other trig functions. You only need to find one of them. But it's the same procedure for question number 25 as question number 26, except that there are multiple procedures. So I showed you one procedure. It's actually my preferred procedure. It's the procedure that uses right triangles and the Pythagorean theorem. An alternative procedure is don't draw the angle, don't draw the triangle, don't use the Pythagorean theorem. Instead, use a Pythagorean identity. So let me illustrate for you how you would use a Pythagorean identity on question number 26. Okay, so here is question number 26 from My Open Math. Instead of drawing a triangle, I'm going to use sine squared plus cosine squared is equal to 1. So, sine squared, negative 2 over 5. Cosine squared, I don't know what cosine theta is, so let me just write cosine of theta. So let me point out this for notational purposes. These two things mean the same thing. The cosine of theta then gets squared. It means the same thing as this. The reason we put the squared right here is to prevent confusion because neither of these are the same thing as cosine of theta squared. Cosine of theta squared is where you square the angle itself and then you take the cosine of that angle, where in the case up here, we find the cosine of the angle first, and then we square the value. Okay, so let's go back up here. Negative 2 over 5 squared is, of course, 4 over 25. And on the right-hand side, I have 1. But I can also write the number 1 as 25 over 25. Then I subtract 4 from both sides. 4 over 25. So that leaves me with the cosine squared of theta equal to 21 over 25. Now, the square root property allows me to take the square root of both sides. Remember that this square root symbol needs to go all the way down to include the denominator. And secondly, remember that when you take the square root of both sides, you also have to add plus or minus. That's very important. So the question is the cosine of theta equal to the positive one, which would be the square root of 21 over 5, or is the cosine of theta equal to the negative version of this number? So is the cosine of theta equal to the square root of 21 over 5 or negative square root of 21 over 5? How do we know? Theta is in the third quadrant. In the third quadrant, x is negative. Therefore, cosine is negative. So I reject the positive and I keep the negative. So now I have found one of the 5 that I'm looking for. The other ones, though, follow very quickly. Let me go ahead and write cosine theta up here. And erase the board so I can fill in the other 4 trig functions. We next can find tangent of theta by using the quotient identity sine over cosine. The sine is negative 2/5. The cosine is negative root 21 over 5. This is a complex fraction that will simplify to 2 over root 21, and then you need to rationalize the denominator. Okay, so that is tangent. So the tangent has been found, the cosine has been found, the sine we already knew. The other 3 are very easy. because they are reciprocals, right? So to find cosecant, flip over this number. To find secant, flip over that number. And to find cotangent, flip over that number and rationalize any denominators, and you are done. So that is a little bit more complicated. There are multiple videos you can watch between question 25 and question number 26. There are 3 videos. Plus, in addition to that, there's explanations in 1.4 of how to do these problems. So read the book, watch the videos until it really clicks. You don't want to get by on procedure only. You really want to internalize understanding. And the first time you do a problem, you may not understand it completely. You may be going through the motions. That's okay. But then on day 2, day 3, day 4, sometime in the coming week, as you continue to practice the concept again and again, start to internalize the concepts. You'll notice the way I've done the course is that you have homework due, and then on the same concepts, you have a quiz due. But the homework is due a class day before the quizzes are due. I say class day as Tuesdays and Thursdays because those are the days that I post the lectures for you. And also those are the days that things are due, right? But you can watch these whenever, and you can turn them in before Tuesdays and Thursdays. But you're going to want to just get the problems right by the time you turn the homework in. But by the time you do the quiz, really aim to understand the concepts. And if you need to rewatch some of the videos, watch multiple videos taught by different instructors, all saying the same thing in different ways, until it really solidifies in your understanding. Remember that your goal for the course is comprehensive mastery. One more thing I would like to say real quick is that Chapter 1 was introductory topics, and we went through them very quickly, all of Chapter 1 in one lecture, because much of this is either something that you have seen before, or just a few things in here are simple new concepts. As we go forward in the course, we are going to slow down. I chose to go fast here at the beginning because when we get further in the course, it's going to get a lot harder, and I'm going to want to make sure that you understand the concepts. In order to give you enough time to understand the concepts, I needed to go fast at the beginning so I can slow down later. So if you have questions, try to find me in the Math Homework Lounge. I will try to show up here or there. My schedule is a little unpredictable right now as the school year is getting started, but I will try to be available more predictably as the semester goes on. Okay, I will see you again in the next lecture, which will be posted on Thursday.